So the final rule we're going to look at here is the sum rule for antiderivatives. And it's called the sum rule because it works when you are adding two functions together inside of your antiderivative or indefinite integral calculation. And all it says is you can split and you can make the indefinite integral of the sum of the functions be the sum of the indefinite integral of the functions. So this plus, you can kind of split the indefinite integrals. Another way to say this is the sum, indefinite integral of the sum is equal to the sum of the indefinite. So this is one of the times where it's nice and it works the way that you might think it should work. Let's see what that looks like. So let's look at the indefinite integral of 2x cubed plus 5x to the 7th dx. So using the sum rule, the first thing we're going to do is we can split this up into the indefinite integral of 2x cubed dx plus the indefinite integral of 5x to the 7th dx. From here, we're going to take these constants, this 2 is being multiplied and this 5. You can use the constant multiple rule to pull these out front. The next thing is we're going to have 2 times the indefinite integral of x cubed plus 5 times the indefinite integral x to the 7th. And then we apply the power rule. So we get 2 times 1/4 x to the 4th plus 5 times 1/8 x to the 8th plus c. Finally, we can clean this up just a little bit more. 2 times 1/4 is 1/2, so this becomes 1/2 x to the 4th plus 5/8 x to the 8th plus c. And this is the nice final answer that we would like to have at the end. Okay, so let's look at this next example. Find the indefinite integral of 3x to the pi plus 7 over x to the 4th dx. The first thing we're going to want to do is split this up. So this can be the indefinite integral of 3x to the pi dx plus the indefinite integral of 7 over x to the 4th dx. And then it's important that I rewrite this so that I recognize both of these are actually power functions. So with this x to the 4th in the denominator, this can become 7 times x to the negative 4th. I'm going to rewrite this as indefinite integral of 3x to the pi dx plus the indefinite integral of 7x to the negative 4th dx. Now both of these are going to be, one more thing I can do is I can pull this constant out front, and it might be worth doing that since we're so early in this process. So rewrite this as 3 times the indefinite integral of x to the pi plus 7 times the indefinite integral of x to the negative 4th. And finally, let's identify the powers. So here, k is equal to pi. So k plus 1 is equal to pi plus 1. And here, my k would be equal to negative 4. So k plus 1 would be equal to negative 3. Finally, I'm in a place where I can say, okay, this is going to be 3 times 1 over pi plus 1 x to the pi plus 1 plus 7 times 1 over negative 3 x to the negative 3 plus c. And it's probably, since I've come this far, worth going the final step of rewriting this as 3 over pi plus 1 x to the pi plus 1 plus 7 over negative 3 x to the negative 3 plus c. Key is I'm taking this and I'm applying all of my rules. I have sum rule, constant multiple rule, power rule, and at the end of it, I'm able to take indefinite integral of something that looks kind of complicated. Let's look at this final example, the indefinite integral of 2 times x squared times x cubed plus 7 square root of x dx. And the key here, again, is our first step is going to be to rewrite this algebraically. So as we're rewriting it algebraically, let's look for what we can do. Okay, x squared times x cubed, I'm going to add the 2 and the 3. And so this will become 2 times x to the 5th. And this square root of x, remember that square root of x is equivalent to x to the 1/2. So I'm going to rewrite this as 7 times x to the 1/2. And now I've rewritten it this way. Now with the sum rule, I can take this and split it up into the definite integral of 2x to the 5th dx plus the indefinite integral of 7x to the 1/2 dx. And then with constant multiple rule, I'm going to pull these things out front. So this would become 2 times the indefinite integral of x to the fifth plus 7 times the indefinite integral of x to the 1/2. Now, on both of these functions, I can apply basic power rule. So here the power of k is equal to 5. So k plus 1 would be equal to 6. And here the power k is equal to 1/2. So k plus 1 would be equal to 1/2 plus 1, which is 3/2. Taking these and putting all of these pieces together, this is going to become 2 times 1 over 6 times x to the 6th plus 7 times 1 over 3/2 x to the 3/2 plus c. And I mean, we've gone this far. We might as well do this last little bit of taking 2 times the 1/6 and getting 1/3 and doing 7 times 2/3. So I have 2 times 1/6 x to the 6th plus 7 times 2/3 x to the 3/2. And I can combine these and get 1/3 x to the 6th plus 14/3 x to the 3/2 plus c. And this is the most simplified version I could come up with. It's algebraically equivalent to this, but it's good to go all the way and get to this final piece.